Hey there, and welcome to Extending GitHub. In this session, we're going to take a look at some ways you can extend GitHub's core capabilities by writing extensions and integrations. At the end of this presentation, you'll feel ready to build developer tools of your own that enhance your developer workflow, promoting productivity, code quality, and security for yourself, for your team, or even for the whole wide world. I'm so glad you could join me, and let's get started. So I'm Steve, I'm a product manager here at GitHub, responsible for GitHub's public programmatic interfaces, which we'll look at here shortly. Here's my profile page at github.com/Swinton, and here's the machine readable representation of that page in JSON. The machine readable representation actually exposes some additional data. So we can see here that I became a user of GitHub actually way back in 2008, which by my reckoning makes me a GitHub teenager, and I'm pretty much okay with that. And so I've always kind of loved this idea of machine readable representations of our data. I love the freedom and power this gives us as developers to kind of unleash our creativity, to take this data exposed over APIs from our favorite platforms and remix it and reuse it in interesting ways. We can have fun with this and create things in the world that empower us, make our lives a little easier, and make the lives a little easier for those around us as well. And I love that GitHub embraces this idea, exposing APIs that underlie objects on the GitHub platform, commits, issues, pull requests, and releases, and empowering us as developers to interact with those objects at a high fidelity, creating rich experiences of our own. And so if GitHub is the world's developer platform, then I like to think that the APIs and primitives that support that platform must be the world's developer platform. Okay, JK, I just made that up. That's definitely not a thing, but it'll work for our purposes here. So today we're going to look at this developer platform. There are some recent and perhaps some not so recent changes that you may have missed, so let's bring you up to speed. So there are three kind of main primitives to be aware of, often used in conjunction. We have APIs, webhooks, and actors. APIs allowing for the rich retrieval and manipulation of resources on GitHub over a programmatic interface, typically expressed through JSON. Webhooks kind of allow for the consumption of events on GitHub, such as commits being pushed or code being released, and allow for kind of programmatic reaction to those events. And actors are the entities that authenticate and are authorized to programmatically access and manipulate resources on GitHub over the API. So these are powerful primitives for extending GitHub, and GitHub uses these as well to build GitHub products like Dependabot, GitHub Connect, and even code spaces and actions to some degree. So our vision is for a rich developer tools ecosystem built with the same primitives that we're using to build our own products, empowering developers everywhere to build, discover, and use the tools they need to be productive. So I'm going to spend a bit of time digging into actors specifically here, but before I do that, let's take a quick look at webhooks. Webhooks is this device that allows the push of data versus you having to be responsible for fetching data and ensuring your system or integration is up to date. You don't need to call an API to get new data. GitHub will just send you the relevant data automatically at the appropriate moment to the URL you specify. And you can subscribe to the events that are interesting to you, such as when code was pushed, a PR merged, or a release created. You can use these webhooks to capture data, reflect changes in a downstream system, or perform some other automation like publish a release digest to a mailing list. So that's kind of a high-level overview of the main platform primitives, APIs, webhooks, and actors. I do want to spend a bit of time looking at actors specifically, the entities that authenticate and are authorized to programmatically access resources on GitHub over the API. Historically, these actors are synonymous with the users of GitHub, that's folks like you and I, and this concept was solidified with the advent of OAuth apps and personal access tokens. Personal access tokens were introduced way back in 2013 and this sort of convenient way, super convenient way to create an API token for personal use without using your password, allowing you to auth to the GitHub API as yourself. And we can see how easy it is to create a PAT in the UI and then use it in the API, just a few clicks and a few lines of code, and we can have some automation built. This simplicity and convenience does kind of come at a cost though. In this example, I'm just creating an issue in a repo, but the token I have can do a lot more than that. Ideally, I would be able to create a token with just the right amount of access needed to get the job done. And ideally, I would never be required to give a token to a third party. A personal access token should strictly be for personal use only, right? So this is sort of the direction of the platform. We're investing in fine-grained programmatic actors that enable just the right level of access needed to get the job done, complemented by secure authorization workflows for granting third parties fine-grained access to your resources. So this is the direction GitHub is moving in with regards to our developer platform. And I would like to say the future is fine-grained. But also, while the future is going to become increasingly fine-grained, we can access the benefits of this model right now. So it's in this context, this idea that fine-grained is now, I'd like to reintroduce, or perhaps it's an introduction for the first time, the concept of GitHub apps. GitHub apps are a powerful and secure mechanism for extending GitHub. They encapsulate all of the primitives that we've seen so far, APIs, webhooks, and fine-grained actors. And typically, they materialize as these autonomous, fine-grained, event-driven bots that enhance your software development workflows. But you may ask, how do I even GitHub app? Well, let me show you how. So there are 3 steps to this. The first step is kind of the registration of your app itself on GitHub. This will kind of define what it can do and set up some other metadata associated with the app, like a name and a URL. Then there's the installation of that app somewhere. So that's the thing that will grant access to that app to things on GitHub. This is a bit like inviting a collaborator to your private repo, except that collaborator isn't another user, it's an integration represented by a GitHub app. And then the last step is the actual interaction. What is the value that that GitHub app provides to the places where it's installed? What are the events it reacts to? How does it consume the data? And what does it manifest or manipulate in response to those events? So rather than telling you, it would be helpful, I think, probably to show you. So here is a short demo. So here I am on my organization page wanting to register a new GitHub app owned by this organization, and I can jump over to the settings page for my org, select GitHub apps, and create a new GitHub app. I can give it a name. Pull request bot is what I'm going to call my bot here. A description, a homepage URL that provides some more information about my app, the webhook URL, which is just the URL my webhook events will be sent to, and I'll use my ngrok tunnel. It's a great idea to have a webhook secret, and I can define the permissions, in this case just read-write access to pull requests, and I'll subscribe to the pull request event. We'll say that this GitHub app can be installed on any account because you only live once. Okay, so here is our new GitHub app with an ID of 6 that can interact with pull requests, and I'm going to give it a little logo just to smarten it up a little bit. So I'm going to upload that. That looks good. And I'm going to generate a private key and just download that locally. We'll come back to that in a second. Cool, so the next thing I want to do is authenticate with our REST API as the new app. You might have noticed we have not yet created a token, so how do we auth? Here's the endpoint I'm going to use in our docs here, just git/app, and it's telling me I need to authenticate with a JWT, or JSON Web Token. So let me pause on the demo real quick for a short aside so we can demystify JWTs. This is simply an open standard that enables the kind of secure representation of claims between 2 parties. And here we're going to use a JWT to securely represent a claim about our GitHub app identity to GitHub using the private key that I downloaded. Here's what a JWT looks like. It consists of 3 separate parts: a header, a body, and a signature. And all 3 are basically base64 encoded JSON objects. We can actually decode these base64 representations to see what's going on. And the important thing here is the GitHub app ID is part of the body. which will show to GitHub that we are the GitHub app we're claiming to be, right? So let's go ahead and do this. We need to generate a JWT for the GitHub app I just created, and I tend to use a CLI to make this a little bit easier. And I actually love using this .nvarc approach in VS Code, which gives me this sort of folder-based environment configuration. And I'll set this up to configure the environment for the GitHub app I just created, the ID, path to the private key, and the secret. And there's the command to create the JWT that we need. So let's give this a whirl. If I switch now into my folder, I should see the JWT automatically. And now I should be able to call that endpoint get/app using curl, passing in my JWT via the authorization HTTP request header. And boom, there it is. There's our app pull request bot with write access to pull requests, subscribed to pull request events, and at this point, 0 installations. So let's go and add an installation. In my GitHub app page, I can select install app, and I can install it on an organization that I own, on either some or all of the repos. And in this case, I'm just going to choose all. And then we have an installation of my app, and we can see there in the URL, we have the installation ID as well. And now if I query my app again, just replaying that previous request, I can see that the installations count now has increased from 0 to 1. And I can look up the specifics of that installation via a separate API route, get/app/installations, and then we can see what the details of the installation that we have. So there's the same ID again, ID of 3. We can see it's installed on the demo days, organization with access to all repos, and the same permissions and events that we specified earlier. So the last kind of piece of this puzzle, we've created an app, we've installed it somewhere. The next piece of the puzzle is to do something interactive. This is where the fun starts, right? We simply have to determine what we want our new GitHub app to do. So this is a little bit of a contrived example. It's really just for demonstration purposes, and I think it will work. But let's just say that our GitHub app pull request bot is going to listen for new pull requests on the repos that it has access to. If the title of the pull request includes the robot emoji, then our pull request bot is going to really love that, and it's going to automatically approve the pull request. Let's take a look at this in practice. So here's a repo that I've cloned locally to work with. It's really just a very simple webhook handler written in Golang. It's going to respond to the pull request event we're listening for, and it's going to say, if my pull request title includes the robot emoji, the handsome robot, then I'll approve the PR saying looks good to me. Otherwise, if there's no robot, we'll request some changes saying we need some more robots, please. Then we'll submit the pull request review. So yeah, very simple webhook handler, about as simple as you can get. And there's some instructions here in the README telling me how to go ahead and run it. So let's run this webhook handler. I'm using this reflex command, which just gives me some nice auto reloading based on local file changes. And then I can expose my webhook handler to the wider world via my ngrok tunnel, so it's now kind of reachable by GitHub. So with our app running, let's go open a new pull request and interact with our bot. So here I am in my spoon knife repo, and I'll propose a new file here, bots.md. So let's draft this. That's looking good. And I will create a new branch and propose this change via a new pull request. So here's my PR, I'll make a title, and you may have noticed that the title did not include the bot emoji, so quite rightly our bot has requested some changes. I can't complain with that. So let's go ahead and fix that and make sure we're keeping the bot happy by updating the title, and I'll just add in the robot emoji. And now the bot has approved. So this is all kind of working as expected. One thing that's kind of cool is that our bot here is kind of like a user, but actually it's a little bit different. It's showing up as a bot. So what this means is if we go to the bot profile page, and I just have to sign in again here quick. So if we go to this bot profile page, it's not a user profile page, it's an app profile page. And from here we can configure our installation, we can create more installations, and we can control the access that our app has. And crucially, since our app is public, we can share our app page with anyone else so they can enjoy the benefits of the goodness we've created here as well. So pretty sweet. So let's quickly review what we just saw. We created a GitHub app. we provisioned access for our app to an organization that we own via a new installation of that app. And without that installation, the GitHub app could not access any private properties or resources owned by that organization. Crucially, all of this happens securely without the need for any manual copying and pasting or creation or exchange of a token or personal access token. And each org the app has access to will be represented by a unique installation of the app. So to summarize, GitHub apps are a powerful and secure method for integrating with GitHub. GitHub is being built with GitHub Apps 2. Products like Dependabot are a classic example of a GitHub owned and operated GitHub app. And the same primitives we're using are also available to you to extend GitHub's core capabilities and share those extensions and integrations. If you want to learn more, we have this handy cheat sheet ready to guide you by providing an overview of all of the essential topics available at this URL. But hold on a sec, you may say, what about users? And sometimes you need to authorize GitHub users with your integration as well to understand who they are and even act on their behalf. And we do provide this capability as well with GitHub apps. You can identify your users with your GitHub app using an OAuth flow called the authorization grant flow. We also have the device flow, which is a great way to identify and authorize users from a headless app such as a CLI tool or a Git credential manager. So let's talk quickly about an important design principle with everything we're doing with GitHub apps, which is that there is no escalation of privilege. So what does that mean in practice? And here's a quick worked example. So imagine we have a user who happens to have access to 4 organizations on GitHub. And now let's say that there's a GitHub app which has an installation on 2 of those orgs out of the 4. So when the user authorizes that GitHub app via the OAuth flow, either the device flow or the web authorization flow, what that means is, due to this principle of there being no escalation of privilege, the GitHub app will only be able to access private resources that both the user and the app have access to. Here's what that looks like in practice. So content created via a user-authorized third-party app is clearly marked as such in the UI. So here's some content I created with the ChatOps bot GitHub app. So that kind of wraps up the overview I wanted to present here of our modern platform primitives. But just in our remaining few moments here, I'd love to share a couple of things from our roadmap that we're excited about and are working on right now. So one idea that we're investing in is taking the concepts and principles of GitHub apps and applying them to the humble personal access token that's been around since 2013, giving us all a more fine-grained experience in our personal programmatic interactions. Introducing a new programmatic actor like this is not a simple undertaking, and we'll be announcing more details as we get ready to ship this. But follow along with the roadmap here and watch out for our changelog for other announcements. Also on the roadmap related to the platform primitives, we're getting ready to introduce API versioning, which actually applies to webhooks as well as API versioning. This will give us a great way to safely evolve the platform without breaking any existing contracts. Breaking changes will be introduced under a new calendar-based version, and integrators can opt into a specific version and be confident they will always be consuming predictable API response and webhook payload shapes. And here's that roadmap issue to follow along as well. Okay, so that just about wraps it up for me for this session on extending GitHub. Thank you so much for joining me. I hope you learned something valuable. Have a great universe and take care.